All right, so what we're going to do today is we're going to do a puzzle. This puzzle is going to be a question I'm going to ask you, and it's going to require your knowledge, and this is 8th grade knowledge of Pythagorean Theorem and algebra to solve a simultaneous equation, a system of equations, to answer an interesting question and then maybe make some interesting observations about it. So I'm going to give you the puzzle, let you have, and then you can pause the video, try and work on it. Then I'll give some hints, and then you can, if you can't solve it, and then you can kind of come back to it and pause again and see if you can work through it. I think it's a fun puzzle. I love math puzzles. If you have math puzzles, feel free to send them to me. Let me give it a try. You know, my friends and I send these around, and we do puzzles periodically. That's what math nerds do, and you know, we get off on doing these types of problems. So, all right. Anyway, let's go. Let's share the screen and solve the problem. Okay. All right. Now, so first of all, I want to give full credit to this puzzle to the mathleague.com. This is where I got this puzzle, and it was sent to me by a very sharp 10th grader, and asked me to solve this puzzle. So, you know, if you can't do this puzzle in 8th grade, no, you have the building blocks, but you may need the perseverance or just some key insight to solve the puzzle. So what I'm going to do is first, I'm going to let you try. Then 2, if you can't do it, I'm going to give some hints. And then 3rd, I'm just going to go ahead and solve. So we're right here on letting you try. So why don't you pause the video? So now pause the video and try. Okay, now I'm assuming you're back, and either you need a hint or you want to watch me solve it. So right now what I'm going to do is I'm going to give you a few hints. So let's look at this right triangle, and let's just draw a picture of it. We're going to draw a picture of this right triangle, and it looks like, we're going to just say it looks like this. What is wrong with my triangles? Let's make their outlines be a size of 4. And now let's redraw it. I like nice solid shapes. Okay, now, and in this right triangle, I've told you it's a right triangle, so we're going to say this is side A, this is side B, and this is side C, the side opposite the hypotenuse. So what we know is that A squared plus B squared equals C squared. What we also know, this is further hints, the sum of the lengths is 1. So A plus B plus C equals 1. And then from B, the average length of the long and short side. So what is the long side? Well, C is the long side, and we'll call A the short side, right? The long side has to be the hypotenuse. So C plus A over 2, the average. This is average length. This is a 6th grade standard. The average of 2 things is adding those 2 things together, dividing by 2, and that equals the length of the middle side. Okay, so now this is our hints. We've decoded our information, and now the solving is going to be you taking the time to work through this problem here. Okay, so let's look at it, and I'm going to solve this, and I'm going to now pause and try. Use your persistence, solve it. Those who are persistent are more successful in math in the long run and more successful in life. This is what Carol Dweck has shown. This is what Angela Duckworth calls grit. I would love to see perseverance and attempt to try and solve this. And I'm going to solve it a certain way. There's a lot of ways to solve this. So pause and try. And then we'll come back. Okay. Now we are back. So what I'm going to do, first thing I'm going to do is I'm going to take A, B, and C, and I'm going to rewrite some of these equations. So let's rewrite this one here. We got C plus A over 2 equals B. I'm going to multiply both sides by 2, and I'm going to get C plus A equals 2B. Okay? Now I'm going to take this second equation here, and I'm going to say B, let's see, let's go A plus B plus C equals 1. And I'm going to rewrite this one to do C plus A equals 1 minus B. Right? I just subtracted B from both sides. Now I have C plus A equal 2B and C plus A equals 1 minus B. So I can just, if these two things are equal, because I know C plus A is equal to C plus A, I can say that these two things must be equal. Right? If that equals this, and that equals, if these are equal, and these are equal, then those two must be equal. So 2B equals 1 minus B. Let's add B to both sides. We're getting really close. Now we get 3B equals 1. So B equals 1/3. So we've got one of our key pieces. One of our key pieces. So let's go back in here and let's see what else we can do. So if B is equal to 1/3, we can say that, well, let's go back into this guy here and say, well, C plus A over 2 equals 1/3. You know, A plus C plus 1/3 equals 1. That's from this one. So we know that A plus C equals 2/3. And here we have, let's do our, let's multiply both sides. Right? C plus A equals 2/3. And we could have done this one here, and we could get C plus A equals 2/3 too. So A plus C equals 2/3. We know that's true. And we know that A squared plus 1/3 squared equals C squared. That's from this one, plugging in our B. So here we get A squared minus C squared, or no, let's do it the other way around. C squared, well, how about 1/9, and we're going to subtract A squared from both sides, equals C squared minus A squared. Okay, let's multiply this side by 3. This is gonna, let's get rid of our fractions here. So we're gonna multiply this side by 3, and this side by 3, and this side by 9, and this side by 9. And we're gonna get 3A plus 3C equals 2. And over here we get 1 equals 9C squared minus 9A squared. Okay. All right, so let's now rewrite this. Let's try and get rid, let's solve this guy down. I shouldn't have done this. We should have just stuck here with C squared. I made a mistake. Ignore Mr. Lipscomb. We're going to stick here with C squared. We got this one pretty much solved for C squared. So let's solve this one here for C. Here. Let's do the same thing here. Ignore this work here. Let's solve this one for C. And so we're going to get, we had A plus C equals 2/3. C equals 2/3 minus A. Let's multiply, so now Now we're going to square both of these sides. And then we're going to substitute. So c squared equals, well, this pattern, remember, we need to multiply, this is 2/3 minus a times 2/3 minus a, right? That's what 2/3 minus a squared is. So that's 4/9 minus 2/3 a minus 2/3 a plus a squared. Okay, so that equals 4/9 minus 4/3 a plus a squared. So c squared equals 4/9 minus 4/3 a plus a squared. So now if c squared is equal to this, I can substitute it here. And so we can say, well, a squared plus 1/9 equals 4/9 minus 4/3 a plus a squared. Wow, this is going to start to work out really nice. I'm going to subtract a squared from both sides. And I get 1/9 equals 4/9 minus 4/3 a. Subtract 4/9 from both sides. 1/9 minus 4/9 is equal to negative 3/9 equals negative 4/3 a. Multiply both sides by -1, and we get 3/9 is 1/3 equals 4/3 a. So let's multiply. Now we got to multiply both of these sides by the reciprocal. So that by 3/4, this by 3/4. Boom, and I get a, this cancel, 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 cancel. All this fancy algebra, cancel, cancel. A is 1/4. Now I'm going to do a little bit of erasing over here because we're going to bring our last bit of work up here. We have our b and our a. So let's just go ahead and label those guys here. A is equal to 1/4. B is equal to 1/3. So if the sum a plus b plus c equals 1, then I know, let's go back to our original color here, that 1/4 plus 1/3 plus c equals 1. We're going to use this formula to find c. So common denominator is a 12th. 3/12 plus 4/12 plus c equals 1. 7/12 plus c equals 1. So c equals 5/12. And so our triangle is 1/4, 1/3, and 5/12. Wow, that deserves a giant happy cat. We're going to happy cat each of our little calculations here. And that is awesome. Now, for those of you who want to see something interesting with similar triangles and right triangles, I'm going to continue with this on one more page. Ignore this. So I want you to notice something interesting. And here it is. So we have this triangle that we just said was a right triangle, and it was 1/4, 1/3, and 5/12. Well, 1/4 is the same thing as 3/12, and 1/3 is the same thing as 4/12. So I'm just going to erase these guys here. And what do you notice about this triangle? This triangle is in fact a 3, 4, 5 triangle that's been scaled down by a 12. So if I take a much bigger triangle, if this triangle here and that triangle are similar, I'm going to take this one and I'm going to blow it up. I'm going to multiply it by 12, which these two triangles should still be similar, which means they should still have all the same angle measures. And I should still have a right triangle. So if I multiply this by 12, this would be 3, 5. A 3, 4, 5 triangle, which is our simplest right triangle that we know of. And notice, the average of the long and short side is 4. So for those of you who had the keen insight and didn't need to do all of this crazy calculation, the key insight on this puzzle would have been, oh, well, a 3, 4, the key insight, let's write this down. The key insight that would give you a shortcut to this problem would be, 1, I know 3, 4, 5 is a right triangle. The second key insight is, I know 4 is average of 3 and 5. And the last key piece is similar triangles are scaled up and down by dividing or multiplying each side by a constant. So if I had this key insight, I could have just said, oh, well, 3, 4, 5 triangles, the middle side is the average length of the longer and shorter side. If I scale a triangle up or down, the middle side still stays an average of the long and short side. And I could have just scaled that down by dividing the whole thing by the sum of 3, 4, and 5. 3 plus 4 plus 5 equals 12. Divided each side by 12 and gotten my answer. This, if you followed that last bit of logic, happy cat to you, it's a lot. So either way, if you had the key insight, double pat on the back, double happy cat, and baby happy cat, and grandkid baby happy cat. And otherwise, I will leave this puzzle now and let you be on your way. I will add this to the collection under Fun Math, also to the end of 8M3, just because I promised to you guys who did 8M3 lesson 14 said I'd do it. All right. Happy testing, happy math, happy cat.